Hey guys, today we're going to be talking about some graphs of linear equations that are a little bit unique, a little bit different than most of them we've been looking at. So you'll see a line that's graphed here, pretty straight across horizontal, right? Well, that's a little different in itself, isn't it? Usually we've been looking at lines that are slanted in some way, slanted down or maybe slanted up, going uphill or downhill, if you will. This one's just flat. What does that mean for its slope? Well, let's think about slope in a perspective of rise over run. Sorry, I got a ton of stuff from my last video still there. So slope is rise over run, right? So let's think about this. As this slope moves, how much does it rise from one point to another or anywhere along this line? How much does it rise? Well, it doesn't rise at all, right? It never goes up. All it ever does is go side to side. So it has a rise or a y value, a change in the y direction of 0. Now its change in the run direction could be anything, or the horizontal direction. If we're looking here to here, it might have moved 3 in the horizontal, or it could move any number of spaces. The fact of the matter is, the slope has a numerator of 0. Now, any fraction with a numerator of 0 is equal to what? Yeah, that's right, 0, right? That's just how math works. It's kind of like if you multiply a number by 0, you get 0. If you have 0 in the numerator of a fraction, that number is just 0. And that's what our slope would be in this problem. There would be a slope of 0. Now, we do still have a y-intercept to the line. We have a y-intercept right here. That's where it crosses the y-axis, right? If we start at the origin, look at this vertical y-axis and say, oh, well, it crosses here at 4. It has that y-intercept of 4, but it's got that slope of 0. We can actually still write a slope-intercept form equation out of this. We can write y equals the slope, or well, in this case, 0x plus b, or plus 4. Now that's a technically correct way of writing it, but let me ask, is there a reason to write 0x? Is there a reason to say we have 0 of something? No, there's not. We don't ever have to write 0 times anything. So we could just actually write this equation as y equals 4. Even though it looks really simple, that actually is our linear equation. It's the same kind of thing as, we've talked about some linear equations that don't have a constant, or the constant's 0. This is like a problem that doesn't have a slope. The slope is 0. It happens sometimes. So I wanted to go over what that looks like. I have one other problem I want us to talk about too, though. Let me get that line graphed here for us. I forgot to turn off my screenwriting tool. I wish I could still click around the screen whenever I use this, but it doesn't like me to do that. Alright, so here we have a slightly different one. We have a vertical line, a line straight up and down. So let's think in this problem, what is our rise over run? This is kind of opposite, isn't it? If we think about how much does this rise, well, how far do you want me to check, right? It looks like it rises an awful lot. Let's say, though, we chose this point and this point. Well, from here to here, it rises 5 units. Okay, sure. But how far does it run? How far does it move horizontally? It doesn't, right? Kind of like how that last problem didn't move vertically, this problem doesn't move horizontally. It doesn't move in the x direction. So I'm going to write a 0 there. Now this one's a little bit weirder. Previous problem, we had a 0 in the numerator, and we were pretty comfortable with that. We said, well, 0 divided by anything is still 0. But can you divide a number by 0? Can there be a 0 in the denominator of a fraction? Is that even possible? It's not actually. Like, surprise, it's not actually a thing. This is what we call, and this is an important term, undefined. So if we have a vertical line like this and we ask ourselves, what is the slope? The slope is undefined. Anytime you have a fraction with a 0 in the denominator, that number is undefined. That's just what it's called. So that's what we call the slope here. And it's not actually possible for us to write a slope-intercept form equation of this. We just can't. We can write an equation of it. And I'm just going to go through that here real quick for sake of showing it off. But can't write a slope-intercept form one. To write the equation that we could write, we would say that, usually we look at the origin and go up or down on the y-axis and see where it crosses. But since we can't do that, we can't look at the y-axis in this one because it doesn't cross it, we look at the x-axis instead. And we say, oh, well, it crosses the x-axis at 2. So our line would say x equals 2. Saying it crosses that x-axis at 2. That's not going to come up much, especially in the unit that we're talking about in our class right now. But just for posterity's sake, wanted to mention that. All right, guys, this was all about zero slopes and undefined slopes. If you have any questions, please do let me know. Otherwise, thanks for watching.